Hi and welcome to today's tutorial on DC motors. This tutorial will be presented by Team A2 from Central Queensland University and will explain how briefly a DC motor works and how to build a simple motor yourself. To make a simple DC motor you will need the following equipment: a 9-volt battery, copper wire, a magnet, 2 paper clips, battery clip and a piece of mounting cardboard. Other necessary equipment is scissors, glue stick, ruler and tape. Tightly wind the copper wire to create a coil. Wind completely approximately 15 loops and leave 5 cm of free wire at both ends. These two free ends of the wire should be 180 degrees apart when the winding is complete. This is called the rotor. To secure the loop shape permanently, wrap each free end through the loop and around the coil of the wire 2 to 3 times. Make sure the binding loops are 180 degrees apart and wrap tightly around the coil wires. Check the balance of the coil armature by spinning the coil by the axis between your thumb and index fingers. Sand off the top half of the insulating enamel. Do the same to the other free end. Make sure the shiny bare copper side faces up on both ends. Bend the paper clips into hooks as shown. Attach the paper clips to the cardboard block. Place the coil onto the hooks in the paper clip posts. Place the magnet beneath the coil armature. Connect the battery clip to the 9-volt battery. To start the DC motor, give the coil armature a slight spin. Be sure to disconnect the battery from the clip to turn off the motor. The DC motor was discovered by Michael Faraday in 1851 while doing work with electromagnetics. A DC motor works by Faraday's law of induction. This states that a circuit with a current in it creates an electromagnetic field. This electromagnetic field then repels the permanent magnet underneath the coil, creating torque, rotating the motor. For our simple DC motor, the current flows from the battery to the paper clips, then along the coil of copper and then down the other paper clip, completing the circuit. The current only flows through when the one side of the copper that has been half shaved is touching the paper clip. The reason why the only one side of the copper is shaved is otherwise the magnetic field will repel and the coil flip and then they would attract each other, stopping the motion.